learners, in today's session we are moving forward to the components of a building. We will be breaking down the essential parts that make up a building, giving you a brief understanding of each element's function and its significance in construction and design. We will be discussing about the following key points: general functional requirements of a building, key elements of a building, and then the components of a building. First is general. When designing and constructing a building, both the overall structure and its individual components must be carefully considered. This involves not only ensuring that the building is structurally sound and functional, but also that it meets aesthetic standards. Additionally, achieving these goals should be balanced with cost effectiveness. Efficient planning is crucial for the functional design of the buildings and its important considerations for civil engineers. It involves ensuring that the buildings and its component meet essential functional requirements, optimizing performance and design efficiency. Then the next is basic functional requirements of a building. A well designed and a high performing building should meet several fundamental functional requirements. First is structural integrity. The building must be robust and structurally sound to withstand normal loads and stresses without compromising its safety and stability. Then the sufficient stiffness. The structure should maintain adequate stiffness so that its functional integrity is not decreased over time due to wear or degradation. Then the user comfort and convenience. From a performance perspective, the building should be planned to provide maximum comfort and convenience to its occupants. To satisfy these basic functional requirements, a building must be designed and constructed with the following attributes in mind: comfort and convenience, dimensional stability, then the durability, then the economy, and fire protections, heat or thermal insulations, light and ventilation, moisture or damp prevention, security against theft, sound insulation, strength and stability, then the termite control. So, first is comfort and convenience. Comfort and convenience are fundamental to the functional planning of any building. To achieve this requirement, consider the following points. First is lighting. The building should be designed to provide adequate lighting during both day and night, minimizing glare to enhance visual comfort. Second is orientation. Proper orientation of the building should maximize the benefit of natural light and ventilation. Third is living and working conditions. The design should cater to the living, working and health conditions of the building occupants. Then the space utilization. Rooms should be grouped and planned to ensure optimal circulation, effective space utilization and maximum efficiency. Then the dimensional stability. Dimensional changes in building materials and structures can arise from several factors. First is elastic and plastic deformation. These changes occur due to the applied loads and the material's response over time. Then the thermal expansion and contractions. Variations in temperature or moisture content can cause the building materials to expand or contract, leading to cracks. Then the chemical reactions. Interactions between building materials and the environment can also cause dimensional changes. To prevent such changes, the following measures should be taken into account. First is elastic deformation. Address this by using the effective modulus of elasticity in design. Then the plastic deformation. Incorporate proper load factors to guard against failures. Third is building selection. Avoid materials prone to the significant deformation due to the moisture or temperature changes. Then the shrinkage and expansion. Minimize unnecessary restraint to the shrinkage or expansion of materials. Then the material flexibility. Use materials with high flexibility to prevent cracking under stresses. Then the next is durability. Durability refers to the period during which a building remains habitable and functional. Factors influencing a building's durability include: first is maintenance level. Regular or effective maintenance is crucial. Then the second is construction methods. The techniques used during the construction plays a significant role in life of a building. Then the third is material types. The choice of materials directly impacts durability. Then the exposure conditions, weather, environment, site location and the building height affect durability. Then the frost action, the impact of freezing and thawing on exposed materials. Then the salt crystallization, movement of groundwater can lead to salt deposits affecting durability. Surface erosions, rainwater can erode building surfaces over time. Then the sunlight, prolonged exposure to sunlight can degrade materials like paint, plastics and the rubber. To enhance and maintain durability, consider the following steps. Protective features, incorporate elements such as projecting eaves, copings, sunsets, cornices and the parapets to shield the building from weather effects. Then the design considerations, pay attention to design, maintenance practices, material choices and protective measures against weathering. Then the fourth is economic. Economic considerations should be integrated at every stages of functional planning, design, construction, maintenance and operations of a building. A building should be both functionally and structurally sound without incurring excessive costs. Then the fire protection. To safeguard a building against fire, first we have to material selection. Use composite and non-combustible materials for constructing walls, columns, beams, slabs, etc. Then the fire safety standards, ensure the building adheres to the specified fire safety standards including the provision of fire suppressors and sufficient quick fire exit. Then the planning, reduce fire risk through carefully planning of the building's layout both horizontally and vertically. Then the heat or thermal insulation, effective thermal insulation helps reduce energy cost for heating and cooling. To achieve this, we should consider thicker exterior walls. These provide both structural strength and insulation against temperature extremes. Then the cavity walls, external walls with cavities help in insulating against heat and cold as the air gap acts as a barrier. Then the insulating materials, use materials like slag, wool, lightweight concrete, rock wool and foamed slag aggregates in walls, roofs and floors. Then the architectural features, incorporates elements like chhajjas, canopies, verandas and gardens to add in heat insulation. Then the terrace insulation, economically insulate the top terrace using special flooring techniques. Then the next is light and ventilation. Proper light and ventilations are essential for creating a healthy and comfortable indoor environment. Daylight, position and size the doors and windows to allow ample daylight to enter without glare, enhancing the living and working environment. Then the ventilation, ensure good airflow throughout the building to maintain air quality and control humidity, odor and pollutants. Adequate ventilations help prevent excessive carbon dioxide accumulations which can hinder breathing and overall comfort. Then the ventilation serves the following multiple purpose: air quality, prevents high level of carbon dioxide and other impurities. Then the odor and smoke control, helps suppress odors and smoke concentrations. Then the humidity management, controls moisture condensation on the surfaces. Then the body heat management, facilitates the removal of heat generated by the occupants. Then the preventing suffocation, ensures that the space like conference rooms and halls remains safe and breathable. Then the moisture of damp prevention, a critical requirement for any building is to remain dry condition. Moisture can significantly reduce the structural integrity and durability of a building. To prevent moisture ingress, we must provide damp proof courses, provide damp proofing at various levels to block moisture from entering the walls through walls, floors and basements. Then the construction quality, ensure high quality construction to avoid moisture penetration due to poor material or workmanship. Then the waterproofing, focus on areas prone to leakage such as roofs and bathrooms to prevent water damages. Then the security against theft. To enhance the security of a building, strong external walls should be provided to ensure that the external walls are robust. Then the protected openings, use measures like MS grills or concrete jali on windows to deter unauthorized entry. Then the high security systems. In high security buildings, consider installing automatic alarm systems or cameras. Then the sound insulation. Sound insulation is increasingly important due to the rising population densities, changing community habits and increased noise pollution. Effective sound insulation reduces unwanted noise transmission through building components. Building construction, use cavity walls, airtight windows, thick external walls and insulated floors to enhance sound insulation. Interior materials, employ non-homogeneous structures, hollow walls and sound absorbent materials like fire boards and mineral wools to minimize noise through internal partitions. Then additional techniques include floor construction, utilize sound insulating materials and suspended ceilings to reduce noise transmission through floors. Then the insulating materials, apply materials such as cork slabs, bitumen, asbestos and mineral wool to achieve acceptable noise levels as per standards or zoning regulations. Then the next is strength and stability. The structural design of a building should ensure it can withstand all the imposed loads including dead load, live loads and wind loads. Adherence to the latest design code is essential. Key considerations include, first is load calculations. Calculate loads and working stresses according to the latest code, accounting for the effective of plastic deformations and thermal changes. Then the next is design factors. Apply appropriate load factors during the design process to ensure the building's strength and durability. Then the next is termite controls. Termites, oftenly mistakenly called white ants, are not actually related to ants. Unlike ants, which have a longer pair of wings compared to their hind pairs, termites have wings of equal length. There are over 2300 species of termites globally, but only 4% are responsible for causing significant damages to the building. Challenges in termite control. First is difficulty in removal. Once termites invade a building, eliminating them is very challenging. They find abutment food sources within buildings including textiles, woodwork, paper products and plastic insulations of wiring. Termites easily attack these materials and significantly reducing their strength and value. Then the complexity of treatment. Removing termites involves complicated and often costly treatments. It is therefore highly recommended to adopt termite proofing measures during the construction phase to prevent invasion. Then the preventive and treatment measures. Pre-construction termite proofing. To prevent termite invasion, pre-construction termite proofing is advisable. This can include treating the soil with chemicals to create a barrier around the building's foundation. Then the post-construction termite proofing. For buildings already infested with the termites, post-construction treatments involve several steps. One method is to open the earth around the building and treat it with the chemicals. Another method is to drill holes affected masonry and woodwork and inject chemicals under pressure. These methods are complex and should be performed by professionals with expertise in termite control. Then what are the key elements of a building? A building consists of two main parts. First is substructure or foundation, then the next is superstructure. What is substructure or foundation? The substructure, also known as the foundation, forms the lower part of the building, usually situated below the ground level. Its primary role is to transmit the loads from the superstructure to the supporting soil beneath. This includes distributing the weight and pressure of the building uniformly into the ground to prevent uneven settlement and structural instability. Foundations are critical because they ensure the building remains stable and secure. They support the entire structure by bearing all types of loads include dead load, live load and lateral loads. The foundations must be designed to handle these loads without causing any excessive settlement, which can lead to the structural damages like cracks in walls or floors. It also must prevent the soil underneath from failing due to shear stresses, which could cause the building to tilt or collapse. Then the superstructure. The superstructure is the part of the building that is above the ground level. It serves the functional purpose of the building, providing spaces for living, working or other activities. The superstructure includes all the elements constructed above the foundation encompassing walls, floors, roofs, doors, windows and all other components. One critical part of the superstructure is plinth, which is the section between the ground level and the floor roof. The plinth helps distribute the load from the building into the foundation and provides a barrier against moisture from the ground. The plinth is the portion of the structure between the surrounding ground surface and the surface of the floor immediately above the ground. The plinth level is the height at which the floor of the building is constructed, and the area measured at this level is known as the plinth level or plinth area. Then what are the various components of a building? A building typically comprises the following components. First is foundations, second is masonry units which include walls and columns, third is floor structures, fourth is roof structures, fifth is doors, windows and other openings, sixth is vertical transportation structures, for example staircases, lifts, ramps, etc. Then the building finishes. As we can see in the figure, there are various types of components as shown in the figure, such as substructure, footing, plinth level, superstructure, roof level and the various type of levels. And in this also we can see our ground level, damp proof course, brick wall, windows, sill level, windows, water shed or chhajjas, ceiling level, RCC roof level, parapet wall, coping and the bearing courses. So, what is foundation? The foundation is the base of the building and plays a crucial role in supporting the structure. It ensures that the building can bear its weight and the weight of everything inside it. The foundation must be strong and stable to prevent any settlement that could cause structural issues. Different types of foundations are used depending upon the soil type, load requirements and the building design. Common foundations types include: first is shallow foundations, used when the load bearing capacity of the soil is sufficient at a shallow depth. Examples include strip footings, spread footings and mat or raft foundations. Then the deep foundations, used when the soil near the surface is not strong enough to support the load, requiring deeper supports. Examples include pile foundation and drilled shafts. Designing a foundation involves considering various factors such as soil type, load distribution and various type of environmental conditions. It is crucial to ensure the foundation can handle the loads without causing excessive settlement or soil failure. Then the masonry units, which includes walls and columns. Masonry refers to the construction of a building units bonded together with mortar. These units can be stones, bricks or precast blocks and are used to create walls, columns and other structural components. First is stone masonry, utilizes stones bonded with mortar. Stone masonry is known for its durability and aesthetic appeal, often used in foundations, retaining wall and facades. Then the brick masonry uses bricks bonded together with mortar. Brick masonry is widely used due to its strength, fire resistance and ease of construction. Then the composite masonry combines different types of building units to optimize strength and cost effectiveness. Then the walls. Walls are essential components that enclose or divides space within a building. They provide privacy, security and protection from environmental elements like heat, cold, sun and rain. Walls can be categorized into load bearing walls and non load bearing walls. Load bearing walls. These walls support the weight of the structure above them, including floors and roofs. They are crucial for the structural integrity of the building. Then the non-load bearing walls. These walls do not support any weight other than their own and are used primarily as partitions to divide the spaces. Walls can be specialized for following functions. First is cavity walls, designed with a hollow space between two layers to improve insulation and prevent moisture penetrations. Then the party wall, shared wall between two adjacent buildings providing separation and sound insulation. Then the partition walls, internal walls that divide spaces within a building. Then the dwarf wall, short walls used for garden beds or as base walls for fences. Then the retaining walls, used to hold back soil or water, providing supports to the landscape. Then the column. A column is a vertical structural element that transfers the load from the above to the foundations below. Columns are crucial in multi-story buildings to support floors and roofs. They can be made of various elements, materials including concrete, steel and wood. Then the pier. A pier is similar to a column, but is often integrated into the walls to increase its load bearing capacity. Piers help to distribute vertical loads and enhance the stability of walls. Then the floor structures. Floors are horizontal elements that divide a building into different levels, creating additional usable space. They provide supports for its occupants, furniture, equipment and other items within the building. Ground floor. The floor immediately above the ground level, often designed to bear heavier loads and resist moisture. Then the upper floors. These are the floors situated above the ground floors, providing additional living or working spaces. Then the basement floor, the floors below ground level used for storage, parking or additional working spaces. Each floor consists of two main components: subfloor, the structural part that provides strength and stability to support the loads. It includes beam, joists and other structural elements. Then the floor covering, the surface layer that occupants interact with, such as tiles, carpets or hardwoods. Then the floor area, the usable covered area at any floor level. It determines the amount of functional space available within the building. Then we have a parameter called floor area ratio, FAR. It is a measure of total covered area on all the floors of a building relative to the area of the plot of land it is built on, multiplied by 100. This ratio helps in planning and zoning regulations to control building density. Then the next is roof structures. The roof is the uppermost part of the building, providing protections from the environmental elements like rain, snow, sun and wind. It is crucial for maintaining the building's structural integrity and comfort. First is roof decking, the structural components that supports the roof covering. It can be flat, sloping, constructed using materials such as wood, steel or concrete. Then the roof covering, the outermost layer that shields the building from weather conditions. Common materials include tiles, mat, slats, flagstones and corrugated sheets. Roof structures can vary in design. First is flat roofs, provide additional usable space for activities or equipment placement. Then the next is sloped roofs, allow for efficient water drainage and are often used in areas with heavy rainfalls or snow. Then the dome roofs provide a visually appealing and structurally efficient design. Then the next is truss roofs, use a framework of triangular units to support large spans. Then the next is cell roofs, curved structures that offer an aesthetically pleasing and strong design. The next is doors, windows and other openings. Doors, movable barriers installed in wall openings to provide access to different parts of a building. They are typically made of wood, steel or other materials and can vary in design to suit functional and aesthetic needs. Doors provide security, privacy and insulation. Windows, openings in walls designed to allow light, ventilations and views. They are framed and may have shutters for added functionality. Windows play a crucial role in buildings ventilation and lighting and enhancing comfort and energy efficiency. Then the lintels, horizontal structural members placed over doors and windows or other type of openings to support the load from the walls above the opening. Lintels can be made from timber, stone, steel or reinforced concrete. Then the arches, curved structures made of wedge shaped units bonded with mortar used to span openings. Arches provide a strong and aesthetically pleasing way to support loads above the opening. They can be constructed using reinforced concrete for added strength. Then the next is vertical transportation structures. Vertical transportation structures facilitate movement between different floors in a building. They include stairs, ramps, ladders, lifts and escalator staircases. A series of steps designed to connect different floors. Stairs consist of the following components: treads, risers, stringers, naval post, handrails and balustrades. Stair can be constructed from various materials including timber, stone, reinforced concrete or steel. They must be designed to ensure safety, ease of use and durability. The next is ramps, inclined surfaces that connects different levels, providing accessibility for materials with disability or moving heavy items. Then the next is ladders, used for access to small or restricted spaces where stairs are not feasible. Then the next is lifts, mechanized system that transport people and goods vertically between different floors. Lifts are essential in multi-storied buildings for convenience and accessibility. Then the escalators, moving staircases that provide continuous vertical transportation, commonly used in shopping malls, airports and transit stations. Then the next is building finishes. Building finishes serve both protective and decorative purpose, covering various components of a building. They enhance the building appearance, protect it from environmental damage and improve its functionality. First is plastering, applying a thin layer of materials like cement or lime mortar on surfaces to provide a smooth finish. Plastering protects walls from moisture and damage while enhancing their appearance. The next is pointing, finishing mortar joints in masonry for enhanced durability and appearance. Pointing prevents water ingress and improves the aesthetic quality of the masonry walls. Then the next is painting, varnishing and polishing, applied to doors, windows and other type of components to protect and beautify. Painting provides a protective layer against weathering, while varnishing and polishing enhance the natural beauty of materials like wood. Then the whitewashing, distempering and color washing, applied to plastered surface to protect against weathering and improve aesthetic appeal. These finishes provide a clean, fresh look to the walls and ceilings, with distempering offer a more durable and washable finish compared to the whitewashing. Dear learners, we have reached the end of today's session. I hope you found it informative and engaging. Thank you for your attention. See you in the next class. Thank you.